Welcome to Flip Lesson 78 for the 5th grade. You have finally made it to a higher level of education, and now it's time to learn about exponents and square roots. So let's begin. We see our first example on the left. The left says that 3 squared. 3 squared can really be written like this. It's not 3 times 2. Instead, it is really 3 times 3. Exponents. Let's try another one. We see 4 to the 3rd power. Sometimes this is known as cubed. But really, it is not 4 times 3, but instead it is 4 times 4 times 4. There are 3 4s that are multiplied together. Hence, we can see in our last example, 5 to the 4th power, we have 1, 2, 3, 4 5s, not 5 times 4. This is the basic principle that we want to understand as we go through exponents. That the power, or the exponent itself, tells you how many times you need to multiply your base number. So if you have 3 in the exponent, you need 3 4s. Just like if you have 4 in the exponent, you need to multiply 5 4 times. Let's try our example here. It says, write 2 to the 4th power as a whole number. To do that, we need to break this down and understand what it says. It's not saying 2 times 4. That is incorrect. Instead, it is saying 2 times 2 times 2 times 2. And so we can solve this problem. 2 times 2 is 4, times another 2 is 8, times another 2 gives us 16. So in the end, 2 to the 4th equals 16. That's our first underlining idea. So let's solve this problem. It says if 3 times n equals 9, then what does n to the 3rd power equal? First thing we need to do is we need to solve for 3 times n equals 9. 3 times n equals 9. Hopefully this stands out very quickly and you say, wait, 9 divided by 3, n must equal 3. Then we can come over here and say, well, n to the 3rd power is now 3 times 3 times 3, because we need 3 3s. Here's our 3, here's our base number of 3, and so we get 3 3s. Now we can solve this problem. 3 times 3 is 9, and 9 times 3 is 27. And so we have our answer. As we look at exponents, there's much more to exponents than meets the eye. We can see that place values really are an understanding of how exponents work. We see our example. 10 to the 0 power is actually the ones column, because it is, well, it just is. Let's move on. 10 to the 1st power, right? 10 by itself, right? 10 one time is 10. Hundreds, right? 10 squared, we would look at that and say, well, 10 times 10, 10 times 10, well, that equals 100. Just like here, we can see 10 to the 3rd is 10 times 10 times 10, right? This idea now, which is going to give you 1,000. So we could continue on working with this idea, trying to solve these problems. Continuing on then, as we look at this, the question says, what is 10 to the 8th power? 10 to the 8th power, we would see, is really 10 times 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 10. And in the end, we also see another thing. We see how many zeros are there. In the tens, there is 1 0. 1 with the 0. In the hundreds, there is a 1 with 2 zeros. In the tens, thousands, sorry, there is a 1 with 3 zeros. So if we are at 10 to the 8th power, we would have a 1 with 8 zeros. If you don't believe me, multiply all of these tens together. And then I can add my commas in correctly. And so the place value for 10 to the 8th would be 100 million. How can we apply this then? We can use a number like 45,000 and write it in expanded notation with exponents. In the past, we would write 4 times 10,000 plus 5 times 1,000. But now that we understand exponents, we can say 4 times 10 to the 1, 2, 3, 4, fourth, plus 5 times 10 to the 1, 2, 3, third power. And so we have expanded notation. Along with this, we can really start to understand what's known as square roots. We can do this by understanding the area of a square. If a square itself has an area of 25 centimeters squared, that really means is we took this side times this side and we got this answer. So what times what equals 25? Hopefully you would understand that 5 times 5 equals 25. What we have really done here is we've taken what's known as the square root of 25. This is not a division symbol, this is a square root symbol. Square root symbol means what times what equals this number. So it's going to be the same number. In this case, it happened to be 5. So in the end, what is the length of one side? We would say 5 centimeters. Let's try another example. The number 100. What times what, that is the same number, equals 100. And of course, you would say, well, that is 10 times 10. 10 times 10 equals 100. So the square root of 100 equals 10. And then we have a slightly more advanced problem. It says add 9 plus 16, right? Do what's inside first. 9 plus 16 equals 25. And now find the square root of that. Square root of 25 we determined already is 5. Over here it says first find the square root of 9, which would be 3 times 3. So square root would be 3, plus square root of 16, which is 16 is 4 times 4. So the square root would be 4. And 3 plus 4 gives us an answer of 7. And so in the end, the big question is 5 greater than 7? And of course, the answer would be 7. And so we have that idea. As you take a look at exponents today and square roots, you can understand the principles we have here. That is lesson 78.